Okay, since we've been talking about the force of gravity in the last lesson, I thought it would be interesting to take a second and look at tides, kind of a natural phenomenon caused by gravity. So in this video, what I'd like to do is focus on, okay, what exactly are tides? What exactly are tides and what causes them? Okay, what causes tides? So I think here in Utah, we're kind of at a little disadvantage. We're not as familiar with tides and what they are exactly and how they work. So what tides are is along the coast, the ocean has what is called high tide. The water level can come up. And at low tide, the water level might fall back down, even lower than where it's at right there. So there's this region here throughout the day where the tide could be up here at high tide and down here at low tide. So we're going to look exactly look at the physics of what causes tides. So please have your Chapter 6 guided notes open and be filling out the information as we go through these slides. Okay, let's get started. So tides are generated by a couple of things. Okay, tides are generated by the gravitational pull of the moon and the sun. So it's this force of gravity between the Earth and the moon and the Earth and the sun that's responsible for that water going up or going back down during low tide. So I wanted to ask you though and make a prediction. Okay, what do you think is more responsible for tides? Would it be the moon or would it be the sun? So think about that for a second. The moon or the sun, what do you think is more responsible for tides? And the answer might surprise you. You might be thinking that the sun, it's obviously a lot more massive. Here's the sun right here. So you might be thinking because the sun is more massive, there's more force of gravity, so it's pulling the water on Earth, causing the tides, more so than the moon. But in fact, the moon has a larger role in tides here on Earth. Okay, so let's talk about that. So actually, the moon has 2 times greater gravitational pull than the sun for us. And here's why, okay? Here's a depiction of the solar system. So we got the sun here, we've got Earth, and we've got the moon. Now, if you look at this model, it kind of shows how we are related to the sun and the moon in terms of volume or the size of our Earth compared to the sun and the moon. Okay, and obviously the sun looks way more, it's way more massive, it's a lot more volume, so you would think that there would be more force of gravity between us and the sun. But if we look at the model and take into account the distance that we are from the sun, so down here, if this is the sun and this is the Earth, the moon would be right here. So this is a scale to distance. The moon is so much closer to the Earth than the sun is that the moon is responsible for tides it has twice as much gravitational pull on the Earth than the sun does. So we've been studying this equation, Newton's universal law of gravity. It's equal, the force of gravity is equal to the universal gravity constant times the mass of one of the objects times the mass of the other object divided by the distance between those two objects squared. And because the distance is squared in this equation, it's going to play a larger role in determining the force of gravity. And because we are so much closer to the moon, there's just a larger force of gravity, and that's what's responsible for tides. Now they both do. The sun does account for tides a little bit, but the moon twice as much. Okay, we just answered that question. The sun is actually 390 times farther away from Earth as compared to the moon. Okay, so we've learned what tides are when the water goes up, when the water goes down along the coast. We've learned that the moon is more responsible for the tides because it's so much closer to the Earth. So the force of gravity is 2 times greater because of the moon than it is from the sun. All right, I've got a slide here that graphs tides throughout the day. Okay, so if you look at a graph, the first thing that you should do is look at the axes. So on the y-axis, this is average sea level. So at high tide, we're up here, and low tide, we're down here. On the x-axis, we have the time throughout the day. So we're starting at midnight, 12 a.m. And then we go to 6 a.m. and noon, and then 6 p.m. So this is a graph of tides. And so we look here, if we start at midnight, we're at low tide. Well, 6 hours later, we're going to be at high tide. And 6 hours later at noon, we're at low tide again. And then 6 hours more than that, we're at 6 p.m., we're at high tide. So you can see here that we go from high to low to high to low every 6 hours. And I want you to think about that for a second. Why do we go from a low tide to a high tide in 6 hours? And then in another 6 hours, we're back to a low tide. And then another 6 hours, we're back to high tide. Why do you think that is? Okay, come up with an explanation. Why do you think that is? Every 6 hours, the tide goes from high to low. Okay. So here's some facts about high and low tides. The tide will change between high and low tide every 6 hours. Okay, we just saw that in that graph. So it goes between high and low tide every 6 hours. Here's another fact. There's 2 high tides every day. That means there's also 2 low tides every day. There are these extra high tides, which are called spring tides, that are experienced during the full and the new moon. So when we have a full moon and when we have a new moon, along the coast there will be extra high tides, and they're called spring tides. There's also extra low tides, which are called neap tides. And neap tides are experienced during the quarter moon. So when we see a quarter of the moon, there will be extra low tides, and again, they're called neap tides. Okay. All right, I wanted to go through practice problem number 7 with you. So if you're following along in the notes, and I hope that you are, I would like you to draw everything that I draw here, and I think, you know, in all physics problems, when you make a drawing and you try to illustrate the situation, it kind of makes sense a little bit better. So hopefully, as we draw this picture, tides will make sense. All right, so let's read it. It says, make a drawing of the earth and the moon that illustrates how high and low tides are created. So I'd like to start here with the earth. So let's draw the earth. Okay, here's earth. Okay. And let's start off by drawing the moon. Okay, the moon's right here. And we know that there is a force of gravity between the earth and the moon. Now, what's responsible for tides is the fact that this part of the earth, the side that's facing the moon, is closer to the moon. And so we know from the force of Newton's universal law of gravity equation that the closer you are, the greater the force of gravity. So this side of Earth, and particularly this part, is going to be the closest to the moon, so it's experiencing the greatest force. On the poles would be somewhat medium force of gravity, and on the back side of the Earth, because it's so much farther away, it's going to be the smallest force. Well, what that does, because the Earth is 70% water, the surface is 70% water, what that does is pulls the water toward the moon because of that force of gravity. Now, I'm going to draw in the water, and I'm going to exaggerate what that does, just so that we can see it more clearly. If this was the water that I'm drawing here, it kind of bulges out toward the moon, but on the back side it also bulges out. So it kind of forms a football shape. Now, of course, I've exaggerated it quite a bit, but that's what happens to the water. So this would be the water line. Okay. Now, a lot of students can see why the water is being pulled on this near side of Earth, because it's closer to the moon. But they always wonder, why is there a bulge, it's called a tidal bulge, in the back side of the moon, or on the back side of the Earth? So it's we can see this one's closer to the moon, the gravity is pulling it toward the moon, but why is there also this tidal bulge on the backside? And the answer is, you got to think about water. It's all connected, and so if the water is being displaced, it's pulling here, there's a greater force of gravity on the near side of Earth, because it's closer to the moon. Medium force of gravity here, and very little force of gravity from the moon because it's farther away. And so what that does is it actually causes water displacement, and it will look like this. Okay, it kind of looks like a football. Okay, so that hasn't really explained why there's high and low tides every 6 hours. So let's talk about that. Okay? The Earth would always have tides like this if it was always facing the moon this way. But we know that the Earth rotates about its axis. If you're looking from the top of the Earth down onto Earth, it rotates counterclockwise. It does one rotation every 24 hours. So let's say this was let's just say this is noon. Okay, this is noon, and on the beach, this would be a high tide. Water's being pulled, it's a high tide. Okay. Well, 6 hours later, the Earth isn't going to be in the same orientation relative to the moon because the Earth is rotating. So in 6 hours later, it makes a quarter turn. So down here, so if you were here at noon, okay, here's you at noon on the beach, you're experiencing a high tide. Well, 6 hours later, you're going to be in this orientation to the moon, and this would be 6 p.m. So at 6 p.m., you're going to be experiencing a low tide. Okay, and then 6 hours later, I guess this would be midnight. You're going to be over here relative to the moon, and you're going to be experiencing another high tide. Okay, 6 hours. 6 hours later, you're going to be at, I guess it will be 6 a.m. Okay, you're going to be here relative to the moon, and you will be experiencing another low tide. So this bulge, this tidal bulge, is where you see the high tide, nearest the moon, but also opposite of the moon, and the low tides are going to be experienced at this 90-degree angle from the moon. So anyway, that's kind of how tides work and why we see 2 high tides every day and 2 low tides every day. And the answer is the Earth is rotating about its axis. Okay, but we haven't talked really about how the sun affects that. Because the sun, while it's not as dramatic as the moon, it does play into tides. So here's the sun. Now when the sun, the moon, and the Earth are all aligned like this tidal bulge right here is going to be a little bit greater. Okay, and that's where you're going to experience those extra high tides called spring tides. So when you're experiencing a new moon, like this person would experience a new moon right here, you see a spring tide. And also a full moon, you would experience extra high tides called spring tides. Now, when would you experience extra low tides? Well, when the moon and the Earth, or when the moon, the Earth, and the sun form a 90-degree angle. So if this was the moon down here, the force of gravity from the sun and the force of gravity from the moon kind of cancel each other out, and so you kind of see extra low tides during those times. Okay, hopefully that illustration makes sense, and we've answered a few of your questions about tides. All right, I've got a picture of the Bay of Fundy. Some places, because of their geography, the tidal change is quite dramatic. So at high tide, the Bay of Fundy, you can see this boat is just floating in the bay, and everything was normal. But at low tide, 6 hours later, the water has recessed a lot. And now this boat isn't even floating in the water anymore. And so the Bay of Fundy, because of its geography of that area, the tidal change can be quite dramatic. Now in most cases it's not so dramatic, but it still is noticeable. You'll notice a high tide and and low tide every day. So, okay, hopefully that makes sense. I think we're done talking about tides. I just wanted to go into it to about that level. But I wanted to finish up by reviewing what we just talked about. So did you learn what tides are? And it's when water comes up on the coast a little bit higher and it goes down a little bit lower. So we've got high tides, we've got low tides. That's what tides are. Number 2, what causes tides? Hopefully you've learned what causes tides. And it's the force of gravity. More so from the moon because it's closer to Earth than the sun. But they both contribute. Number 3, how many high tides are there in one day? Hopefully you're saying to yourself, there's 2 high tides. Okay, there's 2 high tides in one day. And number 4, how many low tides in one day? There's 2. And finally, did you learn how to make a drawing of the Earth and the moon to illustrate how tides work? And how when the Earth rotates, every 6 hours we go from a high tide to a low tide. Anyway, hopefully that makes sense. And I thought it would be kind of interesting to talk about since we're learning about the force of gravity.